All right, well, I'm going to go ahead and get started just in appreciation of everyone's time. Maybe Mike or somebody can keep an eye on the lobby, and if anyone else comes in, if you don't mind opening the door for them.
Will do.
Perfect, thank you. First of all, welcome everybody. I want to thank everybody for joining us today. It's our very first episode of the Verge Spotlight series. The team here at Verge is linking arms with some of our technology partners. These are unprecedented times, and we're launching the Spotlight series as a way to try and continue to connect with and hopefully bring some value to our current and maybe some prospective clients. We'll be discussing emerging technologies and trends on the lives and the businesses here in Atlantic, Canada. So I'm Mark Hippern with Verge Technologies. I'm excited for you to hear from true industry veteran and professional, Peter McLean from TOA Canada. Peter is going to be discussing mass notification systems, how they've kind of evolved over the years, but most importantly, how they're woven into some upcoming changes in Canadian Canadian building codes. So in appreciation of everyone's schedule, we do have some time slated for questions at the end of the hour. So if you do have a question, please enter it in the chat box, and I'll kind of keep an eye on that and either raise it with Peter as he's going, or we'll go through them at the end. This is our very first session, as I mentioned, so I apologize in advance if we encounter any hiccups. We use Teams platform internally at Verge, and we've decided going to give it a shot for this series. We have 2 more sessions scheduled this week. So tomorrow, Dave McIntosh is hosting our session on collaboration. And on Thursday, Denise Lalonde is hosting a session on IP convergence. If you haven't received an invitation yet to those, shame on us, but you can sign up for those via our LinkedIn page, or reach out to one of us, whoever's kind of got you included on this one. Before I hand the reins over to Peter, I do want to quickly take a couple of minutes and explain how Verge Technologies came to be, as it's really only taken shape the past few months. So Verge Technologies is essentially what was formerly the technology division of VistaCare Communications, the ICS division. We as a team have been in business since 2003, but under that VistaCare Communications umbrella. In January this year, however, the ICS division was bought as part of a management buyout and formed Verge Technologies. It's all the same folks, all the same management. The former management team has become part of the ownership group, as well as continuing in the management role. All of our field technicians are the same great group of people. We've got the same operations team, the same sales team. We've added a few valuable members as well, but it's the same team that the local business community has partnered with for years. So what we've prided ourselves on in the past and continue to do so is the relationships we have with our customers, kind of building that trust and business relationship in helping provide the best solutions in Pro AV, building infrastructure, so structured cabling, and then security and safety systems, which is pretty a broad category, everything from CCTV and access control to nurse call and mass notification. And that's some of what we're going to get into today, is the mass notification piece with Peter. So if you're ready, Peter, I'm ready to hand the reins over to you and let you have control.
Sounds good. Let's see here. Okie dokie. Can we see that PowerPoint on the screen there?
Looks good.
That's good. Okay. I do appreciate the opportunity with Verge to present today, especially the inaugural event. So that's great. Again, my name is Peter McLean, and I'm RSM with TOA Canada. I cover Atlantic Canada, Manitoba, and Saskatchewan. Used to being on the road, but kind of linked and chained to my home office, as many are. Today, we're going to start with mass notification systems, or voice evacuation systems, or what the future is in general, PA. Some of it's a little technical. We don't get into that too heavily, but we'll talk about the functionality of these systems, past, present, and future, and where it's going with regards to the National Building Code. So a little bit of outline. Mass notification is not a new concept. It's been around since the beginning of time, really. If you look at the history of TOA as an example, we started by inventing the megaphone, which is a very early form of mass notification. Back in our Japanese company. So if you've ever seen the Ricola commercial for cop drops, you see a gentleman on a mountaintop with a big cone, and he's yelling Ricola, and he's communicating very old school methods and barbaric methods to a wide area of people, notifying them of, back in then, it could be impending disaster like flooding or something like that. So it's been around a long time in various forms. What's changed over the time is the target audience and methods of delivery, and the information that you want to pass on to the intended audience within the facility. So again, today we'll look at the nature of mass notification, its impact in Canada. And that being said, we'll look at the background of codes, where they've come from and where they're going, what defines emergency communication systems today, what the future will be. We'll talk about the hardware code of ULCS 576-14, which is a mass notification hardware code. Specific requirements for a good public address system. And at the end, we'll just quickly go through some of the products that we do have to meet these needs. In the beginning, so there's a need to warn of impending and impending disaster. And we still have that today, whether it's, I'm based out of just between Fredericton and St. John, New Brunswick, and we're getting into the point in time where we have flooding. So it may be a matter of flooding. It may be a matter of forest fires or any range of different disasters that are commonplace in the area. Building codes, as it is right now, dictate specific requirement as a base minimum. And in the past, they've derived from the military standards. And that's a lot of where the building code and notification fires come from, is the military side. Notification basically involved audible alarms, sirens, and strobes in the beginning of it. Voice command relied on alarm signaling speakers. So if there was voice up to this point in the last few years, it was going through speakers and a fire alarm that weren't designed for fidelity for reproduction of human speech. Work great for sirens, but again, siren sounds a little bit different than a general voice page. Speech intelligibility was not considered or mandated. So how clearly and how accurately you can be heard. I'm probably dating myself, but if anybody's seen old Charlie Brown commercials, you have the teacher in the front of the class going wonk, 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 talking. Nobody's really hearing. It's just background noise because the intelligibility factor isn't there. You're not, accurately hearing what is being said through the system. And the code requirements and compliance is usually handled by the ASJ, so authority having jurisdiction. The codes and guidelines were not law, even in today's standards, but that is soon changing. So we'll pop down a few of these here. So mass notification codes, being a worldwide company and having offices throughout the world, we've been involved in the code in various areas. So there is mass notification codes in different areas. In Europe, it's EN 54. In USA, it's UL 2572 for mass notification. And so we're fairly behind other parts of the world when it comes to what a true mass notification system is. So currently, when it comes to the code, they're under review. And we'll get into, as we dive a little bit further, the current code and functionality, which now I believe I've been told is in the hands of the National Building Code. And we should see that 2020, 2021, so this year or next year. It's unclear how much of the code for mass notification is changed, whether they do it all at once or in phases. But we've been told from the UL committee that that has been passed over for them to adopt, and generally then that filters from the National Building Code down provincially. So that's something that will make it law and a standard of practice. That being said, up to this point, we've been very, very busy ourselves as a manufacturer and companies like Verge on projects that require mass notification currently, like schools, education, manufacturing, because they realize the importance. A lot of companies do operate outside of Canada as well, and they adhere to the standards in those parent countries. So we find without even the mandated code that companies are looking to follow and update their systems. So things that this feature code will address is distributed messaging and alerting, text, video pop-ups, that type of thing. So historically, we looked at maybe a fire alarm system do a mass notification, maybe a tone or a bell or a siren. That tells you something's going on, doesn't tell you what it is. Is it a fire or is it a natural disaster? God forbid, maybe it's an active gun, active shooter situation. So the messaging is a new component to give you some kind of information on what that is. And again, various options of how you can alert. So whether it's texting or network screens that pop up with a message. We really look at wide area coverage. A recent project we did with Verge as well is urban shipbuilding, where we looked at PA within the manufacturing facility as well as wide area coverage outside the area. Redundancy is really critical in the new code. Conventionally, a PA system might include a microphone, a speaker, a microphone amplifier, and a speaker. You make a page happens. You think, you don't know. Maybe again the amplifier, covering the outside of the building isn't working. You don't know that until someone says it doesn't work. Maybe there's a power outage or something like that. So redundancy is really key. As an example, today I'm working on generator power. We had a big windstorm overnight. We lost power at 11 o'clock last night. Haven't gotten power back. So without redundancy, I'd be letting Verge down today. But luckily, I do have a generator and I have backups. I have that redundancy in place, so I'm able to function as normal. So it's nice that this in a presentation have that. But if it's a life safety situation, that's where it's really key. Alarm-specific event notifications. Again, if there's certain things, certain activities, they can trigger a certain event in a certain way of notification. Survivability, hardened, event protected, wide area communication. So basically, looking at very robust systems designed to be on 24/7 and are tested to do so. Speech intelligibility, as I mentioned, even coverage, low distortion. So really looking at design and looking at specifications on the speakers going into the facility and that they are properly chosen, mounted, and spread out to get even coverage and get that intelligibility. Maybe years ago, if you look at a general paging in the hallway, you say, "Oh, let's put a speaker every 20 feet." Well, and no speaker is created equal. So looking at tools and software that can help you and verify. Should it be every 15 feet, 20 feet, 7 feet? What should that be to make sure that as you're in between that speaker, you don't lose that intelligibility? And wide array mass notification, including high power speaker arrays. So large outdoor areas. A number of years ago, I worked on a project in Chester, Nova Scotia, where it was a volunteer fire department, and they wanted nobody's full time, I believe. There may be a couple, but high contingency of volunteers that work in various areas with not good cell coverage. So they worked on basically a high power array to communicate, almost like an old school area siren, to allow notification throughout the community via wide area arrays. So that's another area you can look at depending on what's required. So the code structure affecting design mass notification. So there's different authorities, I guess, included in that. You have the building code. So that's the National Building Code, which is released in Canada, and then eventually shot out to the provinces to modify and massage. Government regulations. If you look at federal buildings, they tend to have a little more stringent regulations on safety and access control and that kind of thing. Life safety codes like UL 2572 in the US or the Canadian ULC S576. Fire code, your national fire code, as well as electrical code. Each one of those divisions usually has that authority having jurisdiction of how things proceed. So how do we get here? As we talked about, there's different, lots of unfortunate events. Whether we look at towers attacks in Saudi Arabia, we look at, Polytech Montreal, Afghan gunmen, we look at 9/11. There's various military civilian issues that have raised the concern about systems and notification within the facility, as well as natural disasters. Again, none of them are good events, but the thing is looking at them and saying how you can effectively control or reduce any harm to the facility and the occupants within is the key strength of mass notification systems and looking at that. What are they? Well, we need them to save lives and property. So anywhere from corporate staff safety to power outages, like I'm experiencing right now, amber alerts, military security, weather, tornadoes, floods, hurricanes. Whether it's public safety, active gunmen, terror attacks, public health, pandemics. Be sure we're in one of those right now, unfortunately. So there may be need. I know with us working healthcare, there's needs to have a robust notification, mass notification system in most healthcare, whether it's in long-term healthcare or in hospitals and that type of thing. So they've been doing mass notification and more redundant systems following this emerging code before it's even, been enacted in the law. So they've realized the benefits of this. And of course, education with school safety and lockdown. So mass notification market, it's segmented into three different kind of categories. We got products. So we have hardware products and we have software products and services. I won't jump too much into the software side, but just let you know that our software companies out there that Verge deals with that can tie into various platforms. Some mass notification systems are audio only. Some do involve multiple technologies. So information text, projectors, screens, strobes, a variety of different technologies. So, it could be fairly simple in the mass notification side or get quite vast. So as I mentioned, when you look at hardware, there's audio components, but then there's more depending on how complex a system the facility requires or you're looking for. And of course, that can always be designed and released there or integrated in stages. By application, emergency communications, business continuity, disaster recovery, public address warning. So what's the application? Is it just to let the facility know something's happening? Or we're starting to notice that, just letting a facility know and the people within that something's happening, maybe we should say, hey, there's an event in the east, the east wing of a building, the north and south. Well, they should be able to exit where other areas may need to huddle in place. So maybe depending on those events, we can give different messages to different areas depending on what's happening. And some people could maybe get to safety a little bit quicker than others. And as mentioned before, a variety of industries from commercial, education, energy, power, healthcare, automotive, transportation, a wide range of industries require certain levels of mass notification. Looking more at the components, is it a local or a global solution? I'll use another example that Verge was involved in and worked on a number of years ago is a large rollout of mass notification in the Nova Scotia community colleges, all the campuses. So that was done via the team with Verge right now and with a lot of TOA gear involved. So a local solution is just one building. So I just have one building, and if something happens there, I want to just worry about that building, people within that building, and notification from that building. More of a global solution may say, now we have to look at multiple campuses, whether there's 13, 14 campuses, and maybe we need a global solution to communicate with those campuses. Maybe it happens on a school board level where it's various schools at different grade levels in a certain geographical area. So again, maybe I know last year there was an explosion at the Irving oil refinery here in St. John. So maybe there's a notification of certain schools in that area via the school board. So that's more of a global solution. So those are discussions that need to take place. Other documents that emerged exist. Tell them the information about the events, wide area notification, reduce risk of injuries and casualties. Live and pre-recorded messages. This is something that people don't take into consideration. Conventional PA systems, and a lot of times in specs, they are called mass notification systems because they're a little bit dated. it just has that microphone, and that may be administration, security, someone at the front desk of your local school. And if something happens, yeah, they can do a live message. But if it's a disgruntled employee or an act of government or something like of great concern, I don't want to be that person there doing a live message. I'm more concerned with the safety. And if I am doing some kind of announcement, I'm probably not very clear and articulate. So pre-recorded messages that are professionally recorded, uploaded to the system that can be triggered automatically depending on what the issue is part of this code. Just because it comes out, touch of a button, and the information rolls out as the facility sees fit. Ability to operate in one or more locations. Again, that redundancy thought. If something happens in a certain area and maybe it's damaged through an explosion or someone takes hold of a certain area, what is my contingency to tie into that system for another area? And that may be remote offsite, or maybe a fireman's microphone on the entrance or something like that. So looking at ability to operate in different areas. Interface with wide area systems, verification, monitoring of key components. Again, I look at and talk about a very basic PA system that has a microphone, an amplifier, and a speaker. How do I know that those amplifiers are working? I don't, unless someone happens to complain. They're not being monitored. They're not being, a lot of times they may or may not be even backed up. So in the case of a massification situation, I really don't and can't rely on those systems. So coming into this code is looking for self-monitoring of the amplifiers. So it's constantly looking at, am I functioning, electronics, amplifiers, and the ability to report that back. So if there is a failure, I can let a variety of notification platforms know, hey, there's an issue with the amplifier that controls the 5th floor, or this building, or that campus, and so on and so forth. We're going to see communication paths and critical components. Sometimes we look at, when we're wiring speakers in certain facilities, a lot of them are, daisy chain from one speaker to the next. Maybe we look at 2 runs of speaker cable that would alternate from speakers. That way, if something gets compromised, you still have half of the speakers working. Or maybe, redundancy in your networking path that talks to these hardware pieces. So it's another key component. Things that also tie into mass notification systems, telephone systems. So again, there are provisions for general paging and general announcements through these systems. And there's levels you can set for priority. So you can look at, a telephone system, as maybe priority 2, but a mass notification trigger is priority 1. Connecting strobes for visual awareness, cell phones, tablets, radios, wireless, any kind of visual aids or display boards, pop-ups. So there's lots of different components that can attach to it. So a lot may be inside your PA, your computers, as I just mentioned. Some may be outside, paging horn, police, screens, sirens. And then you look at your size electronics, your cell phones, tablets, anything like that for notification. So getting into the code that is out right now, and this is complete, I believe, in 2014. So it's been out for a number of years, and it's Canadian code, USCS 576. And it's a hardware functionality code. It's basically the system should do this. And what we're hoping and what we've been told is now that this hopefully is going to be in the next building code this year, next year, it's going to say where it should be used, whether it's buildings of a certain size, how it's going to handle existing buildings and the grandfathering in of said systems and so on. So it's taking the hardware functionality of what a mass notification should do and how it's going to be implemented. So that's the key looking forward as we move on. So I mentioned it is a hardware specification, and its history is from the European EN 54 to the American code 2572 is where it's kind of been derived from. So it defines the features and process equipment must have. So what it should be able to do, not necessarily how it should do it. And this equipment also follows NFPA 72, more the fire side of code. So this is what we need to build, into these systems for future-proofing as we move forward. One functionality is we look in in a mass notification, and specifically an audio system, is what does it need to potentially interface with. One thing new in this code is that a mass notification system, or PA, which is, in essence what it is, just a modern updated version, it can potentially integrate into a fire system. So conventionally, a general PA system we put in now, it would have a muting circuit. So if there is a fire, pole station, or anything like that, it would automatically trigger and mute the PA system. Within ULCS 576, we can now potentially be an addition to the fire system. Later on in the presentation, when I talk about electronics and some of the products we have, by getting approval of that ULCS 576, that's some of the functionality that encompasses, is allows you to connect to a fire system. And that's really because it's not in the building code at this point, which like I said, is coming in the future. It's up to the local jurisdiction whether they approve that or not. Some facilities have, some haven't. But that means that if you choose, that fire signaling can go through the mass notification system and through the mass notification speakers. So it's just an extension on those that fire system. That being said, to meet code, now you have amplifiers and speakers that not only meet mass notification approvals, but also fire signaling approval. So now you're not having multiple separate systems, you're having one integrated system that can work together. There's talk back and forth to indicate mass notification active, between the fire panel and vice versa. So if the mass notification is active, the fire panel knows, and then again, if the fire panel is active, mass notification knows. If the mass notification system is active, it can't override a fire signaling. That's a big change in the code. So again, if it's a mass notification event and it's active gunmen or something like that in a facility or disgruntled employee, we may not just want a siren going off, we want to hit that pre-recorded messaging. And it's very hard to hear a pre-recorded message when you have the sirens going off in a facility. So that's where we may mute them under a certain scenario. Ability to provide manual control and release the fire systems. That interconnection between those two systems must be monitored, and generally in local proximity. And section of how they interface, communicate, priorities are built into the interface section of that S576. Power supplies. I won't get too much into this, but the big thing here is that power should be monitoring. It should be on backup systems. I still see a lot of PA systems that are not on backup at certain facilities. Again, monitoring that if there is a power failure, to know that there's a power failure, and to look at how long the system is needed to be functional. Meaning, if you need to evacuate a facility, how long does that take normally? Is that a 2-minute procedure? Is it a 5-minute procedure? So you definitely want to look at having a redundant power that will exceed that. Within the ULC certification, it gets in the ULC certified backup redundant power supplies that meet that mass notification code as well. So that's a little bit on that. Live voice and pre-recorded messaging. So microphones that are connected are going to be monitored. So I know that they're going to work when I need them to work. Conventional PA systems, there's connection, but there's no self-monitoring. If anybody's familiar with, older CCTV surveillance camera systems, they were analog and they work, but there's no real communication of, either you saw the picture, you don't, but there's no monitoring to say, yes, it is functioning, unless you were physically looking at it. As technology changed and cameras went to IP-based cameras, and there's pinging and communication back and forth to say, yes, I'm functioning. Yes, I'm able to report. That's kind of what's built into this code as well, and even down to the microphones to know that they're functioning. Key parts there: automated and manual alarm signals, all called by zones. Manually generate alerts to priority over automated alerts. So if you need to take control of that system, meaning a microphone located near where the entrance would be of a school, then you go in there, pre-recorded message is playing. The person coming in there, whether it's fire or police, they could grab a local microphone and then take control of that to do an announcement if they need to. That's manual paging priorities below there. So that's some new functionality. Status signaling of zones is part of the display information. Any kind of fault and so on must be illuminated and notified. Monitoring and integrity. Any loss of emergency signaling capabilities shall cause trouble in a signal. A failure of digital messaging to play will, cause a fault to let you know. These faults don't turn the system off. They just tie into a platform to allow you to know that something's happening. And it could be right down to, power supplies that are maybe, per se not a clean source. I've had our demo system set up in trade shows where, again, the audio or the power there is not very clean. There's lots of other things being run on it, so that causes the fault. Let you know, hey, there is your power source is not the cleanest, may cause issues down the road. Monitoring integrity. I'm not sure what's next. On the connectivity, it even involves speaker monitoring and supervision that way. So a conventional amplifier, you tie your speakers to it. Again, you make that page, you assume that that page is going through. You don't know if maybe there is renovation at a certain wing or part of an airport, and a line got cut or severed for whatever reason, whether intentionally or by accident. So monitoring of speaker runs will trigger a fault saying, listen, this zone of speakers is no longer functioning. So it allows you to preventatively go out and take a look and rectify the situation before there's an issue that causes loss of information to be transmitted. That's key on the integrity. Shared systems with non-emergency security, building controls, and other non-fire equipment. This is kind of a long run-in sentence from the code, but the key thing is that we cannot cause a fault that would stop another system like a fire system to do its main function, which is notify of fire. So though we talk about faults and things like that, none of that, they're always just a notification, not a stoppage of functionality. So that's one key thing within the code is although we're notifying, we're not stopping basic need and functionality. So another review side of some of the things we have talked about within the code, you get live paging, zoning capabilities. So conventional PA requirements, whether that's from a phone or a microphone, to page into certain areas. And that could, again, be local or could be global. Digital messaging and zoning capabilities with digital messaging. So again, if I need a certain message to go to a certain floor and not to another floor, I can totally customize depending on what the requirements are. A lot of time looking and working with a client on mass notification, there's multiple parties involved. You'll have maybe the audio side of the facility that takes care of PA. You'll have potentially the network side that takes care of the infrastructure. You'll also have the security side that is looking how they want to handle certain troubles or certain concerns that they have within that facility, all working together to find that solution, which may dictate, again, do I need 8 zones or 7 zones or an all call in the solution that they're looking for. The functionality for various priorities: fire alarm, fire supervisory, building, trouble, live voice, text to speech, and any non-emergency communications. Live speaker monitoring, as I spoke to earlier, as well as critical monitoring of communication path, inputs, the microphones, and so on, anything connected to the amplifiers. Alert signals when, as I mentioned, the fire alarm systems. If there's no communication within 30 seconds to allow you that. Distinctive tones, pre-announcement tones. Redundancy, power supplies, a lot of stuff we just already covered. Fault status, so on. Dedicated communication network. That's something that some facilities look at just running their PA mass notification on a dedicated network as opposed to a network that may be shared with students and so on, just to make it a little bit more secure. So looking at the history of the code, we look at NFPA 72. It's kind of an American code that looks at fire and risk assessment. So they are kind of based on location. Client establishes base requirements and risk assessment. It's usually that's the security team looking at that. The ASJ oversees the implementation, information of clients' requirements to meet those assessments and needs. And that ASJ would, anybody that has the authority to look and approve what that facility wants. That doesn't have to be a fire marshal. That could be Verge saying, okay, client, you have this concern, this concern, this concern, this is assessment of your facility. This is what needs to take place and be implemented to meet all of those concerns. And it's not a law-based thing, it's a matter of functionality based. So S576 is looking at the hardware specifications, as I mentioned, and using emergency communication systems. Does not specify how features are accomplished, only that it has it and has the ability. That it does have redundancy for backup amplifiers. So if an amplifier fails, it can notify you, but you can also add a redundant amplifier so it'll automatically switch to a backup amplifier should that happen. So it has that functionality. Guidelines for minimum responses, priorities, and what is required for product for emergency communication systems. So be aware on 2020 building code, this is the key moving forward, is that this code is coming. Again, there's no exact word that it will be, 2020 building code, or when that comes out might be delayed under the unfortunate current situation, maybe 2021. But definitely be aware of that. I'll show you a little bit about what we're designing. But one area where we've seen a lot of facilities looking at is looking at, if we look at post-secondary and why facilities are looking at safety there. A lot of times it's different, different reasons. One might be insurance discount, liability in post-secondary education. We look at universities that are implementing mass notification systems without it being code. Like St. FX, we've rolled out and worked with them on mass notification, as they're starting to add that to their campuses. It's not code, not required. It's not in the building code yet, but they realize it for multiple reasons. It may be, again, insurance safety. It may be professor safety. It's also, student safety and providing and doing due diligence to provide a safe facility atmosphere for students and employees. So there's areas of that you look at on why you'd want to implement, mass notification in an updated system. Because looking back over the years, it's probably the one system within a facility that has not really been updated and modernized in many, many, many years, and is definitely due to do so under, for various reasons. So quickly look at some things that can be done within mass notification. So the design side of things is key. There's software that we use, and I'm sure Verge uses for speaker placement. We use a software called Ease. Basically, it's an audio modeling software. We take in drawings from a facility, and it can plot out speaker coverage. So within a floor of, I'll use a school of a high school, that given the dimensions that it would require 42 speakers at a certain spacing to get a certain ambient noise level. So this software actually is a version that is designed for evacuation to meet the American and I believe the Canadian functionality USC S576 standard right now. So that down the road, whether it's first stage is putting the speakers of proper type in proper spacing, and down the road updating the amplifiers to meet the spec, or all at once, it verifies that this is what should go in there, and this will meet that requirement for intelligibility and proper coverage. So that's part of the design side of things, looking at mass notification and meeting that code. Because eventually there'll be companies that may come out just like they do approval on fire signaling systems that are going to say, yes, you meet this part of the mass notification code once it's adopted, and that will come into speaker spacing and types and so on and so forth. So quickly give you an example of some, TOA product that has, some of the functionalities that we talked about. A couple slides here, and I think we'll open up the questions at that point. So when it comes to amplifiers, with regards to TOA, we've been around about 80 years. Multiple different amplifiers, very standard amplifiers, up to mass notification. So we were the first Canadian company to get certified for ULC S576 with our VM3000 amplifier. which is what went into Nova Scotia community colleges, which has gone into St. FX and a lot of Canadian installation requiring true mass notification systems. So, it'll allow scalability up to 60 zones. It does have pre-recorded messaging capabilities, does have redundancy of amplifiers, does have speaker supervision. That type of thing does meet fire signaling code. So again, this can connect to a fire system. So as if you have a requirement, you work with Verge on a solution, they may look at that amplifier, depending what your requirements are. As I mentioned earlier, speakers that are connected to meet various codes. So we look at our PC580 speakers at the top, your conventional 8-inch speaker on a 12-inch grill, or paging horns, or service speakers. We've gone through over the past numerous years taking key speakers and getting them approved for mass notification, so your intelligibility factor, as well as fire signaling, so they are approved to transmit tones and things on a fire system. So there's 3 different ones there. You also have pendant speakers on your left, a higher end, more full range ceiling speaker. In addition to that, on the right, you'll see the high power line arrays that we have that can cover maybe an area of 1.5 kilometers if you're looking to cover. We've been involved in projects covering national parks for forest fires out west that happened, and we want to be able to communicate within those national parks in case something is happening. And a lot of times, there's no cell coverage. You have campers and hikers throughout these large areas that you need to communicate with. So we have products to meet those requirements as well. And looking at how a little system example, this is kind of similar to the Nova Scotia Community College, where we have a mass notification amplifier in campus A and one in campus B. On the left, we have speakers tied to it. We have a local phone system tied to the campus A. We have backup amplifiers to campus SARS Building T1 campus A. And we tie it together via an alerting software that will tell us when to play a recorded messaging, where to send it to. We talk back to that maybe and tell it, hey, we have a fault with an amplifier, or zone 2 has been compromised and the cable's been cut, that type of thing. So campus A would be just a local mass notification system. As we add to building 2 in an area, recently worked with community college in St. John as they start to roll this out, and that starts to become more of a global, because you're trying to communicate to multiple buildings, and those can just be added and added more and more depending what the facility requires. And they could be throughout the country. When we get into federal projects, that could be buildings throughout different provinces. It's just a network connection between the two. So the key in that is that, yes, you have that global solution that may be tied together via a network. And again, you want to have a certain protocol that a network has redundancy. But should that network fail, power outage or anything like the blackout we had many, many years ago in Ontario that covered half of North America, that at least you have that local functionality too within that building to pre-recorded messages and so on and so forth. So you have the functionality of a global solution, but the security of a local independent solution. And that's pretty much it for me on that side of things. And if there's any questions, we can open the floor to that. Yeah, thank you.
Terrific. Thank you so much, Peter. I don't see any questions in the chat, but we can give folks a couple of minutes to enter anything that you had on your mind. If you think of somebody, maybe a colleague that might see some value in this, we do have plans to post it on our website, vergetechnologies.ca, and that's why we're all being recorded. But we do truly, we're very grateful to all the folks that have joined and shared some of their Tuesday with us today. Obviously, thanks very much to Peter for sharing his expertise. And if there are any questions, I don't see any questions.
Unmute the mics. Would it be anything?
Yeah, we can. We don't have to type them in, I guess.
Peter, it's Mike. I'm just curious. I know you touched on it briefly, but what do you think the impact's going to be on older buildings? Like, say, an older nursing home, long-term care facility, an old rec center, like do you see the code kind of enforcing that they're going to have to overhaul and have a certain period of time to get these systems installed, or are they going to be grandfathered in and it's just kind of impacting more in that new building going forward?
That's probably the hardest question, the one that comes up the most, Mike. And it's an unknown. I really don't know. The only thing I can compare to is other systems that, if you get to the point where you're adding on to the facility or updating any aspect of it, that's usually when you'll have to bring it up to a current code. To what level, I'm not sure. Again, if you're adding on to a school, perhaps the new part of that school, you'd have to meet the code in the head end, but whether you'd have to rerun wires, that may not be feasible. So it's a bit of an unknown. But looking at other systems, generally, once you jump into that part of similar to the fire code, once you do any kind of renovation, you have to bring the system up to current requirements.
Cool. Cool. Yeah, no, I agree. I think we see it in our business more and more that it's coming up, and it's more about the integration into the other systems. So, you mentioned the projects we've done with NSCC and some others, but it's really, mass notification being, the audible paging system or the voice evacuation system. That's, one component, but it's really the overarching trend of integrating the mass notification system, the fire systems, the physical security systems like access control and CCTV and intrusion alarm, but and then going into that network soft world of desktop notification, mass text messaging, email alerts, two-way radio integration. But it's kind of that one component of taking all those systems and integrating them together is truly the kind of the new norm of where we see everyone going. Of when there's an emergency, it's about getting the information out to the right people as soon as possible. So
right.
Cool. No, thanks for putting this together, Peter, and to you, Mark, for hosting, and looking forward to see folks on future sessions.
Terrific. Thank you again, everyone. If there's something you'd like us to present on, or if you'd looking for some more information, feel free to reach out to us. We're happy to work with whoever we can on this, and obviously we'll do it maybe a little differently than we would have 6 months ago, but we welcome the opportunity and the partnership. And once again, thank you so much for your time, and have a great remainder of your day.
Thank you.
Thank you very much.